In this video, we will introduce the quantities that we use to describe motion when objects rotate. For example, if I have an object going along an arc like this, an arc S, the length of that arc is related to the angle theta by this relationship. This relationship, you have used it quite a bit whenever you use the fact that 2 pi radians is equal to 360 degrees. Whenever you calculated the circumference of a circle, circumference of a circle is 2 pi times r. That's 2 pi in radians. That's the angle, a full 360 degrees to make the full circle. Times r, that gives us the circumference, the length of the arc. So we are going to use angles to refer to the angular position or the rotational position of the object. Displacement then would be referred to as the change in the angle and radians. Now, angular velocity, we are going to use the same definitions that we have used in the past when we dealt with linear velocities and linear accelerations. So, in general, we get the instantaneous rotational velocity, and we use the symbol omega for it, by taking the derivative of the angular position theta. Now, or average values, when things are discrete, the average value for the angular velocity is angular displacement, delta theta over delta t. Same thing for angular acceleration. Average acceleration would be change in velocity, change in omega over change in time. And the instantaneous acceleration, we refer to it with the angle alpha as the derivative of omega as a function of time. The units, angular position is radians, so the angular velocity is radians per second. The angular acceleration would be radians per second squared. Now the direction, angular position is the direction of theta, however that is. But the way we, and how do we determine the direction of theta? If you consider a rotating object, an object rotating like this, think of it as a disk rotating, a merry-go-round. The only thing that does not change for a merry-go-round when it is going around is the axis. And the merry-go-round is going to rotate about that axis in one direction or the other direction. So to refer, to determine the direction of an angular quantity, we are going to take advantage of that axis. And we'll talk about it in another recording of how do we determine the direction along that axis. But that's the way we determine the direction of theta. It's going to be an arrow that points in the direction of the axis. The angular velocity, its direction then, is going to be along the direction of motion, using again the axis of the circle. The angular acceleration, its direction is going to depend on whether the object is speeding up or slowing down. For a speeding up object, it's going to have the same direction as the angular velocity. For a slowing down object, it's going to have the opposite direction as the angular velocity.